Hello students, now we are going to discuss about some basic points in inorganic chemistry. These basic points play a very important role in understanding not only inorganic chemistry but will be playing very crucial role in physical as well in organic chemistry also. Chemical bonding, periodic classification, atomic structure, remaining chapters of inorganic chemistry, S block elements, hydrogen, P block elements, D and F block elements, coordination chemistry, everywhere these points which we are going to discuss today will play a very crucial role in making it easy in understanding the concept and explaining it properly. See, in these important basics in inorganic chemistry, first point is, first we will take an element, corchotobium, rutherfordium or unnil cladium. Its atomic number is 104. See, Russians used to say corchotobium, Americans used to say rutherfordium, and in IUPAC it is unnil cladium. Since atomic number is 1, so for 1 uni is there, for 0 nil is there, and for 4 quadium is there. So nil quadium. So this is IUPAC name. You know this system of giving names to elements having atomic number greater than 104. So now for this element, first point we will be discussing about its electron configuration. If you know Aufbau principle, which is a German word, Aufbau is a German word which means building up. This question was there in Delhi PMT. Aufbau is a German word which means building up. According to that Aufbau principle, electrons will be filled according to the energy level. First electron will goes to the lower energy level, then after the filling of that lower energy level, electron will transfer to next higher energy level. So the electronic configuration according to Aufbau principle for this element will be 7s2 6d2. You know 1s2 2s2 2p6 3s2 3p6, this is Aufbau principle. 4s2 3d10 4p6 5s2, like this we'll keep on writing electronic configuration of this corchotobium element. In 9th and 10th, you were writing electronic configuration as 2, 8, 18, 32 like that. Now, that also we should know. 2, 8, 18. In first shell, maximally how many electrons can be accommodated? 2. In second shell, how many electrons can be accommodated? 8. In third, it is 18. And in fourth, maximally 32 electrons can be filled. What about the fifth shell? We don't know that. What about the sixth shell? We also don't know that. What about the seventh shell? In seventh shell, 2 electrons are there. See, this is sixth shell. In sixth shell, you have written 6d2. What does it mean? It means you have already filled 6s and 6p. So 6s2, 6p6, 6d2. S is having 2, P is having 6, and D is having 2. So total in sixth shell, how many electrons are there? 10. Now see 2 plus 8, 10, 28, 60, 70, 72. Out of 104, you have written here 72, so still 32 are not there. So in fifth shell, 32 electrons will be there. So in this way, without knowing any number of electrons in fifth and sixth shell, that is pre-penultimate shell and penultimate shell, we can remember that too. Now see, this was your first point. Now second point is period. Here in this electronic configuration, how many shells you have written? 1, 2, 3, 4, 5, 6, 7. Total how many shells are there? 7 shells are there. So this element is a member of 7th period. Why 7th period? Because it is having 7 shells. Now see, this element belongs to which block? You know S block, P block, D block and F block. 4 types of blocks are there. They are in periodic table. All elements which are more than 100 in number can be classified into S block, P block, D and F block elements. See here, this last electron enters into D subshell. where last electron is filled in D subshell. So it's a member of D block. This element is a member of D block. So chlorotoluene is a D block element, and as we know, S block elements are light metals except the hydrogen, which is a non-metal. P block elements can be metals, non-metals. Metals means light metals. So P block elements can be light metals, metalloids, non-metals, and inert gases. All four types of elements are there in P block. What about the D block? In D block, heavy metals are there. See, this is your periodic table. S block elements, P block elements, D block elements, and these are F block elements. So all D block elements, all D block elements are heavy metals. Why D block elements are called heavy metals? D block elements are called heavy metals because their density is very high. How we can say its density is high? Why its density is high? Their density, D block elements density is very high because their volume is low. Since their volume is low, so their density will be high. Since their density is high, so that's why D block elements are mostly heavy metals. Densest is iridium, and second densest metal is osmium. Iridium 77 is the densest metal, and osmium 76 is second densest metal. What about the valency of D block elements? You know, valency of D block elements is variable. Most of the D block elements show variable valency. Their valency is not fixed. Their valency is not constant. Their valency is not one type. It can be of many types. It can be many in number. For example, Fe is having valency 2 and 3, Ag is having valency 1 and 2, Cu is having valency 1 and 2, Au is having valency 1 and 3. So mostly D block elements show variable valency. S and P block elements show group valency. Their valency will only be of one type. Now, sixth point is oxidation number. As D block elements show variable valency, their oxidation number will also be variable. What's the reason why D block elements show variable valency? Why D block elements show variable oxidation number? Because in S and P block elements, in case of S block elements, only Ns electrons can take part there in the bond formation. What about P block elements? Only Np electrons can take part there in the bond formation. What about the D block elements? In case of D block element, Ns as well N-1D, both subshells can take part there in the bond formation, and the difference in energy between them, between Ns and N-1D, is very, very less. So participation of electrons from Ns and N-1D subshell will be easily possible. So that is why D block elements show variable valency as